Okay, I think we'll kick off at this point. So this part of the afternoon is all about the artificial intelligence side of things. In Amazon's artificial intelligence casserole, they have 4 different products. We're going to go through these now. We're going to start off with the one that's called machine learning. Now, obviously, machine learning is a huge science. It involves a large amount of expertise and a huge number of machines in order to make the data crunching work in the way that it needs to. What Amazon offers is a self-service version of that. And it's designed to be simple to use and yet powerful in terms of creating predictive analyses. And I'm going to show you 2 different examples of this at work. So machine learning is a service that makes it easy for developers of all skill levels to use machine learning technology. Actually, you don't even need to be a developer to use it, as you'll see. Amazon Machine Learning provides visualization tools and wizards that guide you through the process of creating machine learning models. Cost is 42 cents per hour, 10 cents per 1,000 predictions, and 0.00001 per prediction. Okay. So, in this first example, as I say, there's going to be 2 examples on this section. The first example here is, and these are openly available data sources, which you can download from the internet to run these examples yourself. This is credit card default payments in Taiwan, bizarrely. And so this is data about people who have defaulted on their payments, their monthly payments on a credit card, and it comes from Taiwan. Now, basically, the idea here is you'll see there are various bits of data, including how much they paid on their last payment. And then the key thing is on the right-hand side, we have a column which gives you a value of 1 or 0. 1 is somebody who defaulted on a payment. 0 is somebody who didn't. So to get started, what I want to be able to do is to be able to predict whether somebody is going to default on their, or is it likely that somebody is going to default on their payment of their next credit card installment. Clearly useful if you're a bank or a commercial agency. You want to be able to do this. So again, this is just a spreadsheet. I've put the spreadsheet into S3, the same buckets as we saw earlier on, could come from Redshift. And all I'm doing now is pointing the machine learning tool to the file. I'm specifying a name for it. And now what it's going to do is read the information in from that file. I'm telling it that the top row of information is the field name of each of those. So you can see here education, marriage, payment, and so on, age, the amount of each bill, the amount paid on each bill, and then at the bottom, the default payment. So I'm happy with that. And now what I have to do is say, which of these fields is the one that I want to predict? What is the field that I want to predict? I'm choosing here default payment. So I want it to analyze the data in all of the other fields, and then I want it to predict the default payment, the default field. Okay. So I've gone through, I've accepted all the defaults here. So basically it's just uploading the data and pushing it through. And one of the things they say here is, of course, garbage in, garbage out. If your raw data is no good, you're not going to get good results. You can control how it analyzes the data. By default, it uses 70% of the data to create the model, so to create the predictive model, and then 30% of the data to train the model for information. There's a lot more things you can do to specify under the hood using the kind of customization. So by default, it will run the analysis model 10 times. You can actually do it up to 100 times. And when you do that, it will improve the accuracy of the data. There's a whole lot of stuff you can do under the hood here. But again, this is designed to make it really easy for you to be able to create predictive models. So now I've got this information, it's been ingested, it's going to run off and create the model. It's now done that, and in the process of doing it, it also creates an evaluation. So what it does is it creates the model, and then it takes the information and it runs a test for itself. And this is effectively the result of its test. How accurate has it predicted the results based on the 30% of data it's testing against? And you can see here in this particular example, it's a simple example because it's binary, it's either or. it's got a score of 0.712, which effectively means it's a good score. It's above average score for here for the under the curve value. So I can, however, tweak that. And that's an important point with something like this, because as you'll see in the next one, here, for example, 81% of the guesses were true. There were 379 false positives, 1,281 false negatives. Now, obviously, if you're doing a credit score, you might be much more willing to have false negatives than you are to have false positives. And so you might want to adjust this in order to compensate for that. The overall accuracy isn't going to change a lot, but the way in which it's skewed is going to change a little bit. Once you've actually created this, you can then do real-time predictions. So this allows you, what's important here is, I'm going to do a real-time prediction by putting in a bunch of information here. But you can also create an endpoint. So you can basically create a service where you are able to use that and build that into your applications, or just use it like this to create those real applications. So for example, if I were wanting to increase my credit card loan amount, probably it would be useful to have something like this to predict whether or not I'm in the risk category of defaulting if I were to increase to that amount. Okay. And you can see here, once you actually do that, you can begin to run these tests, and you can change these figures, and on the right-hand side, it will generate the prediction. And you can see here the predicted score is 0.266. And as I begin to change the age, for example, 0.025, it decreases the chance of a default. If I go up to being a 56-year-old, I become 0.38. So it's actually increasing the risk. That's an interesting statistic there. Go up to 68, it goes up to 0.4 option predictability. So when it hits 0.5, it will become likely that I default at this point. And I can do things like changing the education level of somebody, and I can see here how that impacts the score. Of course, the real value is for me to be able to run a whole bunch of tests, but I can see this here. Now, if I go a bit further down to the payment amount, and instead of paying 13,000 off that month, I pay 0. So in other words, effectively, I default. I can start to see some very interesting results, and then I can go back to the age and see how that would impact it, and it starts to bring it back again in there. Okay, so again, the more data you have, and again, any prediction model is only going to be, in this case, 70% accurate. It's going to be skewed by different factors, and the amount of data that we put in here was relatively limited. But the more data you put in, the more you can get out. And so with something like this, you know, as I say, we're then able to, let me just change that back, and then I want to be able to create what they call an endpoint somewhere. It's really there. And this is what I said before, where you're creating a service that can be called. So if I have an application which is checking to see if people are creditworthy or not, this is the one that I might be using in order to do this. Okay, so that's one example. A second example here is where we're taking student data. So I've got some student data here. A bunch of different things might have an impact on the student data. So this is looking at the right-hand row is their attainment, low, medium, high. The left-hand rows show the amount of time that they spent on the subject revising, the amount of time they spent in related subjects, the amount of time that they spent not working on the subject, and their expected and their previous exam score in this subject. So all that information has been created, and this is being used on the right-hand side to generate an expected outcome, low, medium, or high. This is specifically in relation to, I think, electrical engineering. Again, it's a relatively small data set, but if we take this through the same process, we've put it into an S3 bucket, adding that information into the machine learning, runs the process, creates the model. I've got to specify here the target field. Now this time the target field is slightly different, because instead of it being a binary field, it's a categorical field. In other words, it's one where there are multiple different options. So therefore it makes the model more complicated. And again, it runs through. It really does run through. This is just showing that you can use different fields instead of always using a categorical field. But we're going to go back to the categorical field. Goes through, creates. Bingo, there we go. It's ready to generate the recipe and the results. And we create the model at last. Okay. Again, once the model's been created, you have a view on how successful that model was, and it runs an evaluation. Once it's created the evaluation, this one has now got a 0.792 evaluation result. Again, a really good result. Again, this is categorical, so I'm able to explore the model performance rather than adapt it very much. And you'll see here that it shows you a matrix of the expected result versus the hit result. So how successful was the prediction? It's that middle blue level that you really want to look at there. So on the very high, it got 100%. On the high, it's 61%, 68% of low, 82% of middle, and so on. And it shows you where the predictions were that were out the thing. So again, here I am. I'm a tutor. I've got a bunch of students. I want to predict how they're going to do this year. This is a format in which I may want to be able to do this. So I can enter in the various different fields of information. So the amount of time they studied, the amount of time that they spent on related subjects, their last exam grades, and so on, all which are categorized. And I can ask it to make a prediction. And here we go. It gives me the chance of them being high, the chance of them being low, the chance of them being middle, and the chance of them being very low. So here the chances are they're going to be middle. That looks like the most likely outcome by a long way. Now, it's also worth mentioning here that I can actually create a batch prediction. So this is where I'm taking a CSV. So this is another set of data of the students. So this is next year's students where I haven't got the grades, but I'm just uploading the data and I'm running a batch prediction, and I'm basically saying, what do you think is going to be the output of this? What do you think is going to be the result of this? And so this allows me to take a year group, a class, a corpus of people on a corporate training course, and allows me to predict what we think within a 30% deviation will be the outcome. This is also useful to be able to compare the results with what actually were the predicted results as well. So as another test of the accuracy of this model. So these are not results that were used in the creation of the model, but are the same style of results. This will then create the prediction. It will create a CSV of results, which we can open up and compare. In progress. Okay, so there's an output URL, which is where the saved CSV is of the results. Again, I can output it, I can have a look at it. This is also very useful. A good example I've seen used of this is where you have a marketing campaign and you have the results of that marketing campaign, and from the information about the website, you can tell what sort of visitor was the visitor who was successfully engaged in a particular product, or what sort of visitor came to an event. And so you're profiling those visitors at any given point in time, and being able to predict who you should target for the next thing. So here you can see those different examples here. Let's just take the top one. The top one, the actual result was middle, and then if we look there, the chances were 9.8 of it being middle. Second one was low, 9.9 of it being low. Third one was middle, 9.9 of it being middle. So the predictions here are all relatively accurate. Again, this is a particularly good data set because it's been quite well refined. But this is the sort of thing that it can be used for. Very simple, taking information in, allowing the predictive analysis to work on it, and then producing end results. The process behind this is exactly the same as the process, really, behind all of the stuff that we've done before. Everything is going into Amazon, it's creating its own infrastructure that it needs for this process, and it's outputting information. At the same time, it's feeding information back into itself about the accuracy of its predictions and using that to learn to the next level. And that's one of the things that allows us to form the basis of the three other elements that are used inside the AI suite of things for Amazon. And all of these are related to slightly sexier outputs, things that are much more concerned not with the raw data, but with the output of the raw data. So vocal analysis, textual analysis, image analysis. But although we're going to look at those all come from exactly the same space. They all come from the point of taking the data, analyzing the data, millions and millions and millions of pieces of data, and then outputting that information in a useful format. So let's look at my personal favorite, recognition. Amazon Recognition is a service that makes it easy to add image analysis to your applications. With Recognition, you can detect objects, scenes, faces, search and compare faces, and identify inappropriate content in images. I won't be demonstrating the inappropriate content in images. I couldn't think of a safe way to do that one. But what it allows you to do is, if you upload an image to a website to share, it will recognize if it's got an inappropriate thing in it. Costs are: first million images processed are $1 per 1,000. Next 9 million images processed are $80, 80 cents per 1,000. Okay, this is a fun one. So, same thing, okay? We are just looking at exactly the same thing here. Now, what I'm going to do here is try out the demo, and you can see here from Amazon's demo, you can go and do this one yourself. This basically allows you to put in an image, and it will analyze that image and it will recognize artifacts in that image. It's pretty good. You know, some things it recognizes better than others, but it also learns all the time. This process is learning all the time, so it's getting better and better every time everyone scans an image in order to get accurate image information out. Again, same here, city, downtown, metropolis, urban, building, high-rise. Don't know what else you can say about it. Didn't get water. So I'm going to upload a random image here from beautiful Lisbon. Piece of performance art. See how well it does on one of these, which are not the standard ones. There we go. Art, graffiti, mural, wall, flyer, poster, and then it gets down to the ones that are less significant. It will get down to fence, for example. So it's actually being able to recognize those elements pretty well in there as well. So how can we use that? Well, let's go back to our Twitter example. When you scan for Nike, for example, every couple of seconds there's an image uploaded to Nike, or to Twitter, Nike, Pepsi, United Airlines, and so on. So what I want to do is I want to apply this to that. So sentiment analysis, same thing. I want to look at an image eventually. I want to know if it's a positive or negative image for Twitter. So if I'm working for Pepsi and I'm wanting to understand how a brand's being perceived, this is another tool. Now, obviously, as you'll see, there are some limitations. But the core thing is I can take this information in massive amounts. So I'm saving every image, putting it into S3. So a huge amount of data. I'm only using a tiny bit here for obvious reasons. Huge amount of data coming through Kinesis, going through Lambda, saving the image, and then I'm being able to analyze it using recognition. So let's just watch that process in place. And I can do that because I can actually call this in code. So here we go. This is the application that's been built. All I've done here is I've saved the images, and then when I type in this search term, whatever search term I'm typing, put my teeth back in, whatever search term I'm typing in here, it will go off and it will search all of the Nike images, or in this case, first of all, we're doing Nike, all the Nike images, and it will search them for this word. Sneaker, you'd hope so. Okay, So these are just the images from 1 second. I've taken 1 second's worth of data, and it's found sneakers in there. This number of sneakers. Okay. That's not a surprise. Let's try another one. Woman. That's an advert for Cristiano Ronaldo, so I'm not quite sure what they're saying. Okay, let's try this one now. I think this one is Nike. No, this one is Coke. So Pepsi, sorry. So we're searching for military. Now I'm searching for military obviously because I know that given the recent tweets, there's been a bunch of stuff out around here. But you can see how quickly it's coming back with that information. Not 100% accurately, but it's pretty good. Bikini, again, I know that there's this image here that's being around, and so this is creating problems. Let's try United Airlines, just to demonstrate a limitation. Person, okay, you'd hope so. Well, you can see the bad tweets that they got from the United Airlines. Okay. I tell you what, it was great having this weekend to do that one because it was very fun. Okay, let's try another one. Let's try night, much safer one. There we go. Okay, and as you would see, it gets more or less accurate. So that's pretty good in the way it works. Now, if we look at facial analysis, this is another part of the same tool. You can see it picks out the faces and so on. So I'm going to pick one of these tweet pictures out and do a quick facial analysis on it. There we go. He looks like he needs facial analysis. There you go. Appears to be a male, age range, not smiling, not wearing glasses. Now the fact, and also down here, which is not being exposed in the code, is it tells me the emotions associated with that picture. So therefore, although I'm not being able to see this at this point, I am going to be able to pick out the emotions associated with this to use in a moment. So here's another one from United, which I couldn't resist. Appears to be happy. Now this is obviously where the interpretation is at a limit, because yes, he does appear to be happy, but I'm not sure that would be a positive tweet about United Airlines. But the fact of the matter is, it's in there. So I've saved all the information again. Basically, I've gone through and I've pulled out from that little bit of code all of the emotions. I'm saving it in Athena again, just from the images, and now I can go back into QuickSight with that information and add that information to my analysis. Again, nothing here is kind of hidden away. It's all just done by the same process as we got the other information. And you can see here I've got the type of tweet, so whether or not it's Pepsi, whether or not it's Nike, or whether or not it's United, and then associated with that all the various different emotions that there are in there as well. Which makes quite interesting reading. Very small data set, this one. But you can see here, for example, that there were 19 happy people with Pepsi, 9 sad people, and so on and so on. You know, and although this could never be a scientifically 100% accurate process, it is quite interesting in terms of what it's throwing up and how it adds an extra dimension to those pure textual and emoticon analyses from earlier on. Okay, and it's all done exactly by the same process as is being used there. Now the next one is an interesting one. So this is actually being able to take a face and using a photo of that face, recognize other photos that contain that face. So, you know, if you have a huge portfolio of images and you want to be able to find other images that are like that, this is a very useful one to be able to use. There are lots of situations in which you may want to use this. You know, visual search of any nature is very helpful. Find me an image like this one. Okay, so I'm going to take this picture of me and then this picture of me from the internet when I was much younger and half awake. And I'm going to see whether or not it recognizes, I'm glad to see it doesn't match me with any of those people. See whether or not it recognizes this is the same person. So there you go, it's got a 75% similarity between the two. The rest of it is my hair. And here we've got a picture of myself and the other two directors of the Virtual Forge. And you can see here it's matching and picking out that similarity between us. And I am, in fact, myself, which is a huge relief. But the interesting thing here is, again, it's being able to be used as a search. So I'm just going to show you this. So this is basically a video made by DreamTech last Christmas. And what we're going to do now is be able to, within the context of this video, use this process to identify which frames particular stars are in. So this is a very quick overview of the videos. Let's move through very fast. And you can see three main characters, Vicky, Georgia, Mark. And so what I want to do is find out which frames is Vicky in, which ones is Georgia in, and so on. So I'm going to feed in an original image of each of those people. So this is my target image of Georgia. You're welcome. This is my target image of Vicky. And this is my target image of Mark. So all I'm saying is this is the image. Go away and find other pictures, other frames which contain these people. And the way that it's done, and I'm going to require it to have, as you'll see here, what's called the face match threshold. Basically, is set to 60. I'm going to set it to 90. So it's got to be a 90% match. It's got to be 90% sure that this is the right person in this image. So in order to do that, we can then run. Let's go through. So there we go, Vicky. And you can see Vicky is in those. Even though it's tiny little over the shoulder shot, it's picked out those ones there. Let's see how well it does now with Georgia. And you can see it's running through, it's picking, it's processing, and picking. And even here, where she's side on and in a picture, it's picking those out. So that's pretty good. And then the final one with Mark. Again, there you go. All those images, even though it's dark and blurry and not great light there, it's picking out all of those different images as well. Okay. So it's pretty impressive in what it can do, and obviously it has huge benefits in terms of being able to employ it in different searches, being able to use it in a marketing campaign, and especially, as we've talked about, being able to use it in analysis of images and brands and so on of various different natures. Okay, so that's one part. Now, there are two other parts which are both actually very connected with each other. Again, they follow exactly the same process. They're taking massive amounts of data, this time vocal data, spoken data, and they're using that to create effects and events. And the first one I want to talk about of those two is Lex. Now, Amazon Lex is a service for building conversational interfaces into any application using voice and text. Amazon Lex provides the advanced deep learning functionalities of automatic speech recognition for converting speech to text and natural language understanding to recognize the intent of text. So this means that you can create interactive experiences either in text or spoken by using this process. And I'm going to show you both. It's quite astonishing how far and how fast this has come on. And you will have already seen, I'm sure, some of these different things. But the business implications of this in immediate deliverables is, I think, enormous in terms of what it has immediately. So it's $0.004 per voice request, 0.0075 per text request in terms of costs. Now, to give it some context, this is at the core of this. So this is Alexa. I'm sure most of you will have seen Alexa. Alexa is Amazon's speaker that you can get and you put in your house. I'm going to just demonstrate how it works. It works in two different ways, one of which is it just responds to very simple requests. Where's my sound gone? Guys, have we got any sound I can get out of this? Okay, I tell you what I'm going to do to make life easier. I'm just going to take out the sound feed for this bit, because this is going to be a slightly boring presentation if there's no... Hang on. Going to put it in. Just imagine the voice. No, we did have sound earlier on. Okay, so Tristan's here, going to do a dance to cover for me in the. Okay, so we've got a sound issue here, which is. Okay, do you guys have any ideas? If not, then I'm going to just talk over it. Okay, so basically, imagine, if you will, this amazing technology, which actually does work. So basically, the Alexa allows you to speak to it and allows you to have interactive communication. So what I can say to it is, Alexa, what's the news? And it will then give me the latest news. Alexa, what's the weather? And then give me the latest weather. It's a real shame. You can also play games with Alexa, so you can get a two-way conversation. There's a very good game most of you, I'm sure, will have heard of, is rock, paper, scissors. You can play rock, paper, scissors with Alexa, and she'll give you a response. Actually, they don't use rock, paper, scissors. They call it rock, paper, scissors, Spock, lizard, which is much more fun and great fun to demonstrate. But you'll just have to imagine it.
The mini jack?
Yeah, I've tried that. It's not.
No.
It's
Not on mute. No control.
no. Let me try. Oh, there we go.
What's your choice?
Okay. Okay. So thanks to Tristan's technical support. Okay.
Alexa, what's the weather today?
Currently, in Bradford-on-Avon, it's 7 degrees with cloudy skies. Today, you can expect rainy weather with a high of 8 degrees and a low of 7 degrees.
Alexa, what's the meaning of life?
42.
Alexa, open Lizard Spock.
I've made my choice. What's your choice?
Rock.
I choose scissor, but rock crushes scissors. Alexa, 0. You, 1. Ready for another round?
Yes.
Great. Let's continue. I've made my choice. What's your choice?
Spock.
I choose lizard, and lizard poisons Spock. Alexa, 1. You, 1. Ready for another round?
Yes.
Great. Let's continue. I've made my choice. What's your choice?
Spock.
Oops, I chose the same. Let's try again.
Lizard.
Oops, I chose the same. Let's try again.
Paper.
I choose lizard, and lizard eats paper. Alexa, 2. You, 1. Ready for another round?
Alexa, stop.
So.
Okay, our game finished this way. Alexa, 2. You, 1. I won. I'm the best in this game. Come back to challenge me. I'll be waiting for you.
So this is actually really neat, and obviously that's a kind of slightly kind of fun game. But the interactivity, it's still slightly stilted, but it's so much more advanced. And you can build that into lots of different things. In our next generation broadcast pod, some of you will have known, we're building voice control in through using Alexa. And so that's where it's used in the real world. This is the underlying technology behind that. And there are two different ways, as I say, you can use it. One of which is simply using this, which is text-based. So here we go. I want to create a text-based bot. Now, I could do this with voice, as I'll show you. But basically, this is a sequence, a conversation sequence that you can use. And the principle is this. I want to be able to book a trip. So in order to do that, there are a number of things to book a car. In order to do that, there are a number of steps that have to be completed. To the sample utterances, book a car, reserve a car, and so on, are the things that start this process off. So let's just see the voice options that you could have.
Hello, my name is Kimberly. Hello, my name is Justin.
This one's freaky.
Hello, my name is Ivy.
It's like I don't know what that is. That's like,
My name is Joanna.
okay. So I'm here, and these are the questions that are asked. So I can have now, as you'll see, a conversation. And I could do this speaking, but I want to show you the text version first. So I try and type in the question, and it responds automatically. There's nobody there. It's just Alex responding. And it's following this process that's in there automatically. So it's creating what are called intents, and then it has sample utterances, things that you can say, and then it has examples of of the conversation and the process it goes through. It can be very, very complicated in terms of what you can do. And again, this can be a voice-controlled version, but it can also just be embedded into your website just like this to fulfill an immediate need. So it's very useful because it gives the appearance of having your help desk on 24 hours. So you can actually get rid of your help desk, Mike, actually. So sorry. Now, and you can customize it however you want. Now, what's also quite good is you'll see here when you get to channels, you can publish it to Facebook, to Twilio, to Slack, a whole bunch of other places as well. And all you have to do is complete that form, and then it's published out there immediately. So if you're running some sort of campaign and you want to have some sort of interactive thing very quickly published to Facebook, you can do that almost instantaneously using this. You can then take it a stage further, because obviously there's a limit to how many times you want to be able to do that. What if you actually wanted to build I'm not allowed to turn the light. What if you actually wanted to build something for Alexa or for a spoken thing that actually you control and you then push your information out? So this is what we've done here. What I wanted to do is take the Lex technology and not just have a bot like that, although that's great, but I wanted with Alexa to be able to ask Alexa to give me either population information or etymological information about the origin of a country's name. And this is already saved online via something called the CIA World Factbook. So essentially what I want to do is be able to say to Alexa, Alexa, tell me the population of Peru, and it will then go off and it will read the CIA World Factbook page, it will come back and it will then read that information, the result, out to me. And you can do all of that and much, much more very, very simply as well, using the same underlying technology. So this is exactly the same thing. I've just created my World Factbook test page. So this is going to sit inside Alexa or inside my mobile app if I'm not using Alexa. I can just do the same thing as speaking. I can then go in here, and the important thing here is I'm specifying specific countries I want to bring out. Ignore that. But the bit at the bottom, the sample utterances, including one that got a bit silly, the sample utterances are the things that are really important, because the sample utterances are the things that I say and that Alexa will interpret to kick off this process here. So I'm adding my countries in here. Let me just go to the next bit. Here we go, sample utterances. This is what I want to be able to say. I will get there. So I want to be able to say, tell me about blah, Andorra's profile. I want to know about the population of Portugal. Describe the etymology of Saudi Arabia, for example. And so this is then saying to it, okay, once you've heard one of those words, go and run this little piece of code in Lambda. Now, if you remember Lambda from earlier on where we did the sentiment analysis, what I'm doing this time is I've got a little bit of code. All that bit of code does is go off and read the CIA factbook for the country in question and return the information and rebuild for milliseconds for that. So 100, 200 milliseconds worth of information. Now, I then want to test this out once I've uploaded my code to Lambda. World Factbook test, there it is. You know, and think about this. This is just the tip of it. You can effectively, by doing this, give speech control to any application or to any service that you want to deliver. And because the code is all running in the cloud, you can actually have a very cost-effective way of being able to deliver that. Let's see how it worked.
Alexa, open World Factbook.
Factbook. You can ask for the population or etymology of countries. Go on, have a go.
What is the population of Australia?
22,992,654. July 2016 est.
Alexa, ask World Factbook what is the population of Saudi Arabia?
28,160,273. July 2016 est. Note, immigrants make up more than 30% of the total population, according to UN Data, 2015.
Alexa, open World Factbook.
Factbook. You can ask for the population or etymology of countries. Go on, have a go.
What is the etymology of Australia?
The name Australia derives from the Latin Australis, meaning southern. The Australian landmass was long referred to as Terra Australis, or the Southern Land.
So,
Alexa, ask World Factbook what is the etymology of
one more.
Portugal?
Name derives from the Roman designation Portus Cale, meaning port of Cale. Cale was an ancient Celtic town and port in present-day northern Portugal.
okay. So the point here is, okay, this is great, nice little application that does that, but think about it. Any kind of learning situation where you want to have interactive questions, you know, any sort of situation where you want to add in voice control, there's an awful lot of things that can be done using this, and it's all the same thing. It's based on a huge corpus of data, like the machine learning, which is being analyzed by all those massive servers that are coming and going in the cloud, we're then being able to use to generate and understand languages that are being used. Now at the moment this is US English, UK English and German, but obviously it's spreading as they go through as well. Okay. And the final part, the final